Alright, here we go. We're going to do some force diagrams, and we're going to throw numbers into them this time. Here we go. A couple of facts about forces. That is a vector, so it has a magnitude and a direction. So we can exert forces in any direction that we want to, and it's important to know that the directions actually matter. More examples in a second. So the symbol that we use is F for force. The unit that we use is called a Newton, and that is Isaac Newton. So the symbol we use is a capital N. So for example, if I'm pushing on a table with a force of 10 newtons to the right, then what we would write down would be something like, so our force is 10 newtons, and then we'll say it's to the right, so we'll make it positive. Alright, so that is the unit. And in the most general sense, a force is just a push or a pull, and that's all it is. Push or a pull. Here is one example that's really easy. We have a rock sitting on the ground, and by calculating all these forces, everything starts with the diagram. So we know what that's going to look like. It's a pretty easy one. We've got one force up, one force down. One of them is the gravitational force on the rock by the earth. The other one is the normal force on the rock by the ground. And here's your first example problem with numbers. Real simple. If the gravitational force was 10 newtons, what is the normal force? Pretty easy. If those two are balanced, aka they're equal, then that means the normal force is 10 newtons up, and then the gravitational force is 10 newtons down. Let's do another example. It's getting close to the holidays, so here's a sled, and then there's me as Santa Claus, a really skinny Santa Claus. And I'm going to be moving that thing to the right, and I'm going to move it at a constant velocity. The key word here is constant velocity. That means all the forces have to cancel. So I'm going to draw this for the sled. Here is one force down, that's gravity. It has a normal force up. It has this tension to the right, and there's friction. So let's go ahead and start labeling more. If it's at a constant velocity, then all of the forces to the right will cancel out with all the forces to the left, and the same idea for the vertical ones. Everything pointing up will cancel everything pointing down. So there's our four forces. They're all on the sled, so I'll just shorthand this for now. Our tension to the right, friction to the left, gravity down, normal pointing up. Alright, so here are two new questions. Let's say that I told you the tension in the rope is 5 newtons and the gravitational force is 10 newtons. My two questions to you are, what is the frictional force and what is the normal force? And excuse that terrible handwriting at the bottom right. That's supposed to say FN, not F squiggle W. Alright, so if the tension is exactly equal and opposite to the friction, then that means the friction is also 5 newtons, and it's to the left. And if the normal force cancels out with gravity, then that means our normal force is 10 newtons, but is pointing up instead of down. Alright, let's do one where you actually may have to calculate something. So, here we go. I have a box sitting on a hill. The gravitational force acting on that box is 10 newtons, and it's on an incline of 30 degrees. So this should look familiar because this is the trick that I was teaching you last week, where we have to draw a triangle in our force diagram. So let's get our first force diagram down first. Alright, so we have three forces. Normal force perpendicular to the surface. Friction is going up the surface. Gravity will always point down. Alright, so if you look at that, hopefully you know what to do next and how to draw the triangle, which should look like this. So we're going to draw our triangle so that those components of gravity are parallel and perpendicular to the normal force and the frictional force. So that way we can show how they cancel. So the angle of 30 degrees in this point right here is the same as it is here if we draw it in this way. So this is a shortcut so you don't have to do lots of geometry. Alright, so this bottom component here with the double lines is equal to the friction. The other component with the one dash through it is equal to the normal force. Okay, so we can say that by using trig we can figure out what the normal force is and what the frictional force is if we can find the sides of that triangle. So we have a right triangle here, all we got to do is trig. I'm going to give some names to those sides so that we can put it in an equation. You can really call it whatever you want to, but I'm going to stick with these. So I'm going to say force of gravity in our y component, and then our force of gravity in the x component. You can call them whatever you want. I'm just going to call them that so that I have something to write down. Okay, so if we look at the sine of 30 degrees, it's going to be this f of gx divided by our force of gravity, which we know is 10. So our force of gravity in the x direction divided by 10 newtons. Alright, so we can solve that equation for fgx. So fgx is just going to be 10 times the sine of 30. So that means that side length is 5 newtons. Alright, so here's where this all comes together. This right here, actually I will, I'm going to circle this. That right there, this length of this side here is 5 newtons. It is equal to this, which is our friction. So therefore, 5 newtons is our force of friction. Let's do the same thing but with cosine. So the cosine, we're looking at this side right here. We're looking at FGY. So it's FGY divided by 10. So we can solve this for FGY and it'll give us 8.7. So again, this side here, right here, the length of that side is the same as this one. We showed that before. That's why the whole things cancel out. So therefore, the force of normal is also 8.7. Let's do one more example. I'm going to pull a box again, but I'm going to pull it up at an angle. So this will force me to have to use some trig. Alright, so there's our generic force diagram without the components. So my question to you before I reveal the answer is, which one of those vectors do you think is the one that we have to make into a triangle? So if you look here, the ones going up and down are directly opposite, and then the force to the left is going exactly to the left. The only one that's different is this one up and to the right. So we're going to make the one up and to the right into a triangle. So the one to the right now is broken up into those two pieces. So we have one force pointing to the right and one force pointing up. So if we're pulling up to the right, then we can say that some of that force is to the right exactly, some of the force is up exactly. Alright, now we can only say that two of the forces are equal, and it's these two. So the component in the x direction of the tension is equal to the friction, because those are the only two forces left and right, so they have to be the ones that cancel each other out. Okay, let's solve those first. Alright, so let's add a couple of numbers so that we can actually do this. So let's say the force of gravity on the box is 10 newtons, and the force of the tension on that box from the rope is 5 newtons. So our goal here is to find friction and normal force. But let's start with friction because that's the easier one. Well, the frictional force is equal to that x component. So if we use trig, find that x component, we found the friction. So we need to use the cosine. So cosine of 30 is equal to that component divided by the tension, which is 5. So when we solve all that, we get 4.3 newtons. So our friction is 4.3 newtons. Alright, so that was not too bad. Now let's try to find the normal force. Okay, now all of the forces should cancel, so that means everything pointing up should cancel everything pointing down. So here's our first case where we actually have 3 forces to look at. We have normal force pointing up, we have the y component of tension pointing up. So both of those added together have to cancel out with the force of gravity. Okay, so if I solve this for the normal force, that's the thing I'm interested in, all we have to do is find gravity and the y component. We already have gravity, but we don't have this yet, so we need to calculate it. So we can do that by finding the sine. So the sine of 30 is that y component divided by 5. And then when we calculate everything out, we get 2.5. So that's just the y component. We're not done yet. So if you notice, that only helped us find this part, so we need to subtract it from gravity. Alright, so our actual normal force is 10, which we were given, minus the one we calculated, 2.5. So it is 7.5. So those are our two forces here. Alright, I will see you guys in class.